Hello grade 12s and welcome to this video on esters. Esters are largely known for their unique aromas or smells. They are responsible for giving flowers their unique scents, and they are used in perfumes to create the aroma that you get when you spray perfume on yourself. Esters can also be used in the food industry to give flavor to foods and most especially sweets. So esters are a very important type of organic substance or organic compound. The esters have the general formula CnH2nO2. And if you remember, you will know that this is exactly the same general formula that the carboxylic acids have. It is for this reason that when you study isomers, you're going to find that esters form functional isomers of the carboxylic acids. The difference between your esters and carboxylic acids is that the functional group of esters is somewhere in the middle of the chain, and the names of esters end with the word OH. We're going to look at how we can name and draw esters in this video. To form esters, we can react alcohols with carboxylic acids in the presence of heat and a catalyst. Here we have ethanol that we are reacting with propanoic acid. When these compounds are reacted together, the alcohol loses an H, a hydrogen atom, which was initially part of its hydroxyl group. The hydroxyl group is the functional group of the alcohol. The carboxylic acid will lose an OH, which is part of its functional group called the carboxyl. This hydrogen atom from the alcohol and the OH from the carboxylic acid will react together to form a byproduct, H2O, which is just water. Now the rest of the compound, this part of the alcohol, as well as this part of the carboxylic acid, will now bond together. And they will then form the ester, as you can see on the right-hand side of the arrow. In this case, this ester is called ethyl propanoate. Whenever we react alcohols with carboxylic acids in grade 12, they are going to form esters and a byproduct called water. We're now going to look at a few examples in which we're going to either form esters from different compounds or simply draw out the esters themselves. We're going to start off with methyl ethanoate. The first part of the name of this ester, methyl, comes from the alcohol, while the second part, ethanoate, comes from the carboxylic acid. In order to form methyl ethanoate, we need to react methanol with ethanoic acid. When these compounds react together in the presence of a suitable catalyst, like sulfuric acid, as well as heat, the alcohol loses the hydrogen that is part of its hydroxyl group, and the carboxylic acid loses the OH that is part of its carboxyl group. These elements or these atoms are going to react together to form the byproduct, which is H2O, also known as water. And then the rest of the substances are going to react together to form the ester. Methyl ethanoate therefore looks like this. This part comes from the alcohol, and this section over here comes from the carboxylic acid. Let's now look at propyl butanoate. Propyl butanoate comes from or is formed by using the alcohol called propanol and the carboxylic acid known as butanoic acid. When these substances react in the presence of heat and a suitable catalyst, the propanol is going to lose a hydrogen from its OH group or hydroxyl group, and the butanoic acid is going to lose an OH. These will react together to form water. And the rest of the compounds are going to react together to form the ester propyl butanoate. As you can see, this side of the compound comes from the alcohol, while this side over here comes from the carboxylic acid. And this is how you draw propyl butanoate. The last example is a reaction between hexanol and heptanoic acid, and we would like to determine what type of ester is going to form. So we start off by drawing the structural formulae of these compounds. The alcohol has been drawn in red, while the carboxylic acid has been drawn in blue. As you know, the alcohol is going to lose an H from its functional group, while the heptanoic acid is going to lose an OH from its functional group. These atoms are going to react together to form the byproduct called water, or H2O, and the rest of the molecules are going to react to form the ester. In order to name this ester, we're going to have to identify which side comes from the alcohol and which side comes from the carboxylic acid. Since the alcohol does not lose its oxygen, we know that this side over here belongs to the alcohol. It contains 6 carbon atoms, and therefore the first part of the name of this ester is going to be hexanol. Sorry, grade 12, it's not hexanol, but hexyl. And then the rest of the compound, the side in blue, comes from the carboxylic acid, and therefore the rest of this ester's name is going to be heptanoate. And that is the ester that we have formed, of course, in the presence of a catalyst and sufficient heat. Whenever you are asked to name an ester from a structural formula, you're always going to start off by identifying which side belongs to the alcohol, because that is going to make up the first part of the name. Remember that the alcohol does not give up its oxygen, and therefore the side with the single bond O belongs to the alcohol. But the other side of the compound with the double bond O, that belongs to the carboxylic acid and will always make up the second part of the name of the ester that you form. This brings us to the end of this video on esters.